Hey, Desmos team. This is Bo Gibson from Perry Central Junior Senior High School in Southern Indiana. I decided that I would present to you guys a little demo on some of my favorite graphing utilities. It was a tough decision between graphing and the actual activities because I like the activities a lot, but I decided to go with graphing just because I teach more Algebra 2 than anything else this year. And as you guys probably know, Algebra 2 might as well be called Graphing 101. We're graphing about every day. So I'm using this graphing portion just a lot more. So I don't know, that's just kind of my rationale with this. Um, Not that I don't like the activities. I don't know. This is what I went with. I made a decision. I picked it, and I went with it. You can see I'm doing a screencast. I don't know what kind of video you guys were hoping for, but I really have a face for screencast, so that's what I went with. Um, let's jump into this thing. So, obviously Desmos can be used as a graphing calculator, right? We can type in anything we want. It's going to graph it for us, and that's nice. Of course, I guess it's not just a graphing calculator. It's a lot better than the TI whatever I'm sure most people are using in their classrooms. For one, this thing will graph polar if we wanted it to, right? So maybe we do some polar coordinates, and we can graph polar, and we don't have to change modes. We don't have to worry about any of that sort of bulky, kind of out of the way stuff you got to do with the traditional graphing calculators. We can graph things that aren't even functions, right? I could do a circle, let's say x squared plus y squared equals 9, and you can see we have a circle. It's not exactly circular. See, this is kind of an elliptical shape. It appears to be. I could change my viewing window very easily. Again, that's kind of opposed to the traditional graphing calculator, where it's sort of out of the way. You got to get into a separate window, and you got to change that. It's right on the screen with Desmos, which is great. So it's capabilities as a graphing calculator, are great, exceptional. Let's talk about what really sets it apart, though. My class right now, we're just now getting into logarithms and exponents and their inverse nature. So I'm going to run you through a slider demo, and we can see how we can use what we call these sliders um, to really drive home a point. So let's just set up just some sort of random exponential here. So a times 3 to the 3 to the, let's say, just x plus b plus c. Okay, and you see I got all these. I can add a sliders, telling me I can add these sliders. So let's add them all. Before we put anything else on our graph, let's see what we can do. You can see it makes these an adjustable value, and the graph on the screen changes dynamically with our slider here, and we can drag it manually. We can just let it play and watch what happens, and if you let the students at it, that's exactly what they're going to do. And in fact, they're going to play all three of them at once, so you might have to tell them specifically not to do that. But so we have some options. If you notice while I was playing those, you can speed up or slow down the process, and that's nice. Sometimes you want things to develop a little more slowly, sometimes a little more quickly. Of course, I was just manipulating the A value. The B and the C get the same sort of deal. Let's set that to 0 for now, actually. Let's set B and C to 0. So notice I had a hard time getting it to 0 as I was messing around with those point ones. I could always just highlight it and manually type in 0, put it exactly where I want. Also, if I needed that C value to be bigger than 10, smaller than negative 10, I can always just click and I can change. You see it gives me some inequalities. If I wanted it to go from, I don't know, negative 100 to 100, we could do that. If I wanted it to count by not ones, but let's make it count by tens, I could do that. So now you see every time I go over, it's jumping up by tens, and since my viewing window's so zoomed in, you can barely see it. It's up there at the top of the screen. But I could do that if I so desired. It's not really that beneficial to me right now, so I'm not. So we're going to set it back to kind of the default there. And probably I want my step, maybe let's say 0.1 actually. Let's make it step by 0.1. All right, so that's a more smooth jump. Okay, so that's nice with those sliders. What would be really cool though is since we're talking about the inverse nature between exponentials and logs right now, maybe we throw a log graph on there, and maybe we throw a very specific log graph on there. Maybe we throw the base 3 log of x minus c divided by a minus b. Maybe we put that log on there. And you notice I was very specific because I put the inverse. So we have a couple inverses up on the screen right now. And we all know that inverses are reflections of each other over the y equal x line. So maybe we put the y equal x line on there and we make it dashed. Okay. So this is a nice way to illustrate, kind of drive home the point of, the idea that the graphs of inverse functions are reflections of each other over the y equal x line, because we can literally put that line up there. We can dash it to kind of indicate, that's not part of our graphs. It's just a visual aid for us. And now when we slide these sliders around, we can see that no matter what, there's no value of A, B, or C that we can use that's going to make that property not true. Notice, no matter what I'm doing, they're always reflections of each other over that y equal x line. So if that was the point I was trying to make in class that day, I think this is a very, very powerful way to do it. And, like I said earlier, the kids are going to want to play all 3 of those at once and see what happens. And you can say, yeah, shoot, let it happen. See, just let it randomly play. In fact, play one at a different speed. So it really is random. Do you ever see it not be a reflection over y equal x? No, it always is. There's no configuration. That's always, that's just a property that will always be true. So it's a nice way that you can let, the kids are going to naturally want to do that anyway. So you can let it, and you can let it prove your point. So that's one thing I love about these sliders, that we can investigate, so many cases in a very short amount of time. So I love that, especially, like I said, as an Algebra 2 guy. We're graphing every day. We're investigating a lot of different graphs, and these are really nice. Okay, so that's probably, I don't want to say my favorite. Sliders are the ones that I use the most. I use the sliders definitely the most because they can just come in handy in so many different situations. Let's talk about another feature that we can use on these graphs. Okay, so I've cleared out my graph, and I'm back to a blank screen now. So let's say this. Let's say I wanted to get a little hands-on with my kids, and we went outside, and maybe we threw a ball up in the air, and we recorded its height after so many intervals of time, right? So we had some intervals of time, and we threw the ball up, and we just recorded how high it went, just for the sake of argument. And we recorded some data in a data table. So I'm going to switch screens, and we're going to put Excel on the screen. Let's say this was my data table. And I don't know how they measured 4.1 seconds, but so let's just say they did. We can actually copy this. So I've already pre-copied this. And we can go back to our screen, and we can paste our data in there. And look what happens. It automatically takes our data, plots it in a table. So that's another feature that I sometimes use, but kind of skipped over it for this video. Plots it in our table. Notice it zoomed right to a very nice fit. I didn't have that viewing window before. It did it automatically. So that's some really cool stuff. If you could have done this a very similar thing in Excel, but it's not nearly as convenient making that chart. This is just very nice scatter plot we got right here. So of course, if we're doing the statistic, we like to run a regression on it, right? So let's do a regression. So here's how we do a regression. Notice my data, my columns here, it's X1, Y1. So if I type Y1, it's going to automatically make a subscript for me. If I want a regression line, I use the tilde. So we're going to do Y1 tilde. It looks to me like that's parabolic, and the situation I described definitely going to have a parabolic relationship here. So, oh my goodness, look what I went and did. I need to tell it it's X1 here. So notice that it kind of gave me an error message, and that's because my column was X1. and I only had X there. But now I got it matched up, look at that. It automatically draws the regression line, or the regression curve, I should say. It gives me an R squared value. I got a 979 R squared value, so it's a pretty good fit. It even gives me parameters. Okay, so again, in the graphing in a TI, you would have to go to a separate screen and do some calculations. Actually, in 89, you'd have to do a lot of extra stuff. This does it right for you. And we've got our parameters here, our A, B, and C value. We could even plot our residuals. Now, we wouldn't get into that so much in an Algebra 2 class, which is what I primarily teach, but for stats, this would be great. This would be great when we can actually see these residual plots on the same coordinate axis as our data. So I love this feature as a actually, we use this a little bit in our physics class when we collect data from our labs. We'll go back and we sometimes put them in here, investigate our data, look at our R squared and such. So that's a really cool feature. That's something I've never really seen before I started using Desmos quite a bit. Just kind of the ease of getting a regression model based off of some data. Okay, I'm going to switch gears just a little bit. I'm going to show you the last feature I just really love, and that's the pre-made graphs. Okay, so I'm going to clear this off. I'm going to try to get in and out of here, this last little example pretty quick, because I don't know, I just kind of feel bad telling you stuff you already know, but I guess that's what you wanted to hear. So look at all one of my favorite things is you have all these pre-made stuff to think about. As a teacher, I don't have a heck of a lot of time, extra time, to make graphs, make activities, make all this stuff, on my own time. So it's just really, really nice to go in and look at all the pre-made stuff, because the activities have even more than this. And it's just right there on the web app. And I can choose anything. If I'm in a, maybe a pre-algebra class, maybe I could take a look at this slope-intercept form, and sure enough, look at these sliders so we can explore our M and B parameters here. If I'm a little bit more advanced, I'm in trigonometry, I can, pick one of these trig graphs, and we can look at some phase shifts here, right? So that's nice. And again, not that any of these graphs are necessarily truly groundbreaking, but what is groundbreaking is I don't have to make them myself. They're just there for my use, and they're totally free, which is a really, really nice thing. All right, so we got a unit circle, right? Okay, and if you're worried, well, my kids are gonna see all that stuff in the side, and I really don't want them to. Well, you can just let it play, maybe at a really slow pace, and you can hide it from them so they don't get bogged down in all the equation work over there. We can just focus on what's happening, and we can have a discussion as this is playing on my projector. Okay, we can have a talk about what's going on with this point in that triangle. So like I said, really, really good stuff. And these are good graphs, really, really cool to look at. The calculus ones are really cool. This curve stitching gets into some lists, which, again, I don't have time to talk about lists. Lists are another great feature that Desmos brings to the table, but there's so many I can't talk about all of them. I am going to pull up one of my graphs that I made. Okay, I admit I plagiarized a little bit off of a saved graph. I used the same functions, but I did, in my mind, improve upon it a little bit. So you can see I'm trying to demonstrate the fundamental theorem of calculus here. So, you can change these parameters, these A and B parameters, and we can integrate over a larger or smaller interval. And the nice thing is we can see that the difference between, big F of B minus big F of A is, equal to the area under that curve of little f. So we're just trying to connect the algebraic properties to the geometric properties of the theorem. And we can see that no matter what I do with my A and B, the what's in those boxes stay equal. So that's a rundown on, well, 3 of my favorite features that Desmos has to offer. There's a lot more it does, but those were 3 that I wanted to highlight. So thanks for listening to me. Thanks for your consideration, and thanks for your time.